day to all. In this video, we will just analyze the concept of Coulomb's law. When I say Coulomb's law, it was originated from Charles de Coulomb. After the inventor's name, it is called the Coulomb's law. To go into the analysis of Coulomb's law, let us first have an outlook of charge. Rubbing of two substances together transfers outer electrons from one material to another is what we have learnt in our physics analysis. So in the diagram, we have a balloon and a wool material. Electrons are pulled from the wool to the balloon. That's what is shown very clearly, and the balloon has more electrons than usual, which means that the balloon is negatively charged whereas the wool is positively charged. So Coulomb's law we have learnt already in our schoolings, but when I come into the electromagnetic field analysis, it has to be modified in terms of the vector form. I have to speak about the vector analysis, three-dimensional analysis. So it can either be a force of attraction or it can be a force of repulsion. I can choose two charges Q1 and Q2 defined in terms of the distance of r between them, so that they exert the forces of F12 and F21 with distances of r12 and r21 as a unit vector. So a repulsive force or the attraction of force, in general we define the force due to the charge between the two charges is in terms of Coulomb's law, generalized as an equation of F2 is equal to Q1 Q2 divided by 4 pi epsilon of r squared AR12, where F2 is the force on the charge 2 due to 1 and QI is the ith point charge. In general it is, and AR is the unit vector, R the distance between the charges 1 and 2, and epsilon the permittivity of the medium defined as 8.854 into 10 power minus 12 farads per meter. Now the concept map is also very clear in the analysis of Coulomb's law. POS is nothing but a principle of superposition. You are adding a number of charges, so that will lead to principle of superposition. So basic diagram, Coulomb's law, first part is force between two electric charges. Equation is marked over there. In the equation, what all we have is very clearly depicted. Q1 and Q2 are two charges, are the distance between the two charges. So force with which two charges attract or repel each other are not affected by the presence of other charges is the inference. Forces are attractive for unlike charges and it is repulsive for like charges. Also, n vector is the unit vector along the line joining the two charges. So F is a force of attraction or repulsion. The unit of the force is defined in terms of newtons. This on the whole defines the concept map of the Coulomb's law. However, day-to-day application, I can choose the definition of dissolving sodium chloride into water, or it is otherwise the table salt. As it is polar in nature, it gets attracted to the water and gets dissolved very easily. For example, you can define the other case. Oil is non-polar in nature. So when you try to mix it with the water, it doesn't get mixed up in the water. So there is a definition, electrostatic interaction between the solute and the solvent. So the presence of Coulomb's law has been very clearly defined in terms of the condition of the application, day-to-day example. Now next video we will go on for the analysis of static electric field with respect to application of Coulomb's law. Thank you.